video we're going to learn about how to unpack a malware program when you find it packed. So we have seen how to detect packed malware, so it will be best to now know how to unpack it in certain scenarios. So we have some samples here and we'll have a look at them in order to have a context. So when we look at our simple malware, we can see that our import directory this is unpacked. So we can see that it has quite a number of imports. You can see the function it borrows, and we see that it has a text and data section. Now when we look at the packed variants, we'll look at two variants. So the first one has been packed using Empress, and the first thing we see is our import directory changes and there's not so much to reveal. So as you can see, there is very little to deal with. So you can see some functions that we would ideally preempt. As we said, we'll preempt some functions like get module handle A, virtual allocation. So it just depends with what really you would choose to see from static analysis and use as part of your preemption. So the next one is done via UPX, and then we notice again a similar scenario. So as you can see, not much, just a little bit of change in the modules, or rather the strategy used in packing. So that's why you see different functions here as opposed to the one using Empress. Now another thing you'd notice is that we no longer have a text or a data section within our application. So this is mostly the area which is modified whenever you're doing packing. So for purposes of making this easy, we will deal with UPX as it's most commonly used, as opposed to something like Empress. So it's highly likely that this is the kind of packed malware you'd meet. So the first method is really quite easy, the automated method, where we would ideally just use the same utility. So like for UPX, we can just use UPX, decompress, and then output to unpacked.exe, the file which is compressed, and there we have it. So we see we have an equivalent of the previous file which has just appeared over here. So that's unpacked, and when we look at it, we should be able to see a proper import directory, proper section headers, and the likes. So that's the shortcut method, but just delete that to bring us back to context. So let's look at this from a different perspective. When we move to our debugger, we'll have a look at two samples. So let's open the unpacked malware first. So once we do that, as you can see, we have our start point, which is 0412B8, and we're simply pushing elements to the top of the stack, and everything seems good. If we press Ctrl and N, we see the full import table. So we can see even the functions that we were talking about. So this is ideally a very good scenario because we would be able to tell exactly what's happening within the malware. You can just close that and check out the other one. So let's take the packed malware and see what we're dealing with. So when we do the same, we notice there's not so much to deal with. So the import table has been modified, and we notice this is because our entry point is now replaced by UPX. One of the things we said is we need to find a tail jump. So ideally how you would find a tail jump is looking at garbage code. So as you can see, we have so much here that we don't need. It's just null bytes basically. Then we see a jump that goes really way back. So it's a jump to address 004012B8. Now if we were to look at where we are, so we'll just follow the instruction and then you'll see how far the jump goes. So in order to do that, we will set a breakpoint here. We can do that by pressing F2. So we'll just have a simple breakpoint. You'll see it by the highlight, and then we'll run our program by pressing F9. And as you can see, we've hit our breakpoint. Now what we said is, after this point, when we have a long jump, we usually jump to the unpacked stub, because just above it we can see there was a pop AD, which means we popped every general purpose register off the stack. So we're really moving on to good territory, or rather unpacked territory. So we'll just press F8 to move to the next instruction, and you notice the address is similar to what we got in the unpacked malware. So this is the actual entry point, and you see it was the next instruction. In order to use this, we can fix it by dumping the process first. So what we do is dump the process. What we need to do first of all is set the instruction pointer, which is basically this address, to be the original entry point. That's basically what we're trying to say here, so that we can move our original entry point to this point rather than the push AD instruction. Now once we do that, we can create a dump of this file. So you'll just find that it has the appended _ dump. We'll leave it as that to make it easy to follow, and then we'll finish. Now we'll not close our debugger because we need another tool to enable us see a bit more. So again, it's a 32-bit application, so I will just use Skylar, the 32-bit version, but there is a 64-bit in case you need. So what we'll do is attach to the active process. So this is the packed malware as it is in memory because it's running through OLEDBG. So we'll attach to that process, and then what we'll tell it is to search for the address tables, and we will need to manually fix this. So the address here, the original entry point, will need to be set to what we had initially found, which is 04012B8. As you can see, that was a really far off instruction because we were in the line of 8 when we were here. So and then we can just get imports to see whether we're seeing anything, and yes, we can see quite a number of imports now. So what we'll do right now is fix the dump and point it to our original dump file, so that now we can generate a third executable which will have the import address table fixed based on this entry point we found. So once you do that, you notice there's a new one which will be created with _dump _scy.exe. So now we can just kill everything, and this will be our focus. Now the thing about this is that it's not as clean as the initial one, so we'll just close that, and then we'll open up this. So now when this loads, you notice now our application starts at the original entry point. Everything else has been pushed out, and we can see our imports being called right above. And if we try to press the Ctrl N, now we should be able to see everything we had initially no access to. So that's now we are in unpacked malware territory, and our application will stay that way in this particular aspect. So this is the beginning, which is the start of the pointer, and then as you notice we get into the main function. So at least now we have an application that we can poke into, and we can deal with the malware similarly to how we had initially done. So even if you put that in a debugger, you should be able to see quite a bit, or rather a disassembler, you should be able to see quite a bit. So that's the best part about this, because now once you've unpacked it, it becomes easier for you to tell exactly what it's supposed to do. So we'll just do new portable executable malware sample, then we can just pick that, analysis, create imports and resource, yes. As you can see, all our imports are now available. So that's why I'm saying now we've unpacked this malware manually, so now even IDA will be able to analyze it, so it'll make your work quite easy. So from a hybrid perspective, you move from dynamic to static analysis, which you'd not expect, but it works. So as you can see, IDA is still working on it, and it's workable. So once that is done, so let's just compare this address table with what we had initially. So if we take the packed version, As you can see, our imports are still not there. So that's why I'm saying when you do the unpacking, you might want to save it as the third executable, which is why we did that with Skylar. So now we have something that we can use, and this is what made our work quite easy. I hope this has been helpful in understanding exactly what happens when it comes to manual unpacking of malware. So as you can see, we now have everything we need, so the code should be fairly easy to go through now. As you can see, we can still see now everything that is being done, like a registry modification here, which modifies or swaps mouse buttons, creates a no find, and disables Windows Update. So now the regular IDA analysis can now happen without any problem, and we can see exactly what the malware does really. As you can see, no active desktop, no folder options. So all these registry modifications can now be seen. No set taskbar, no log off. So that's basically how to do it, and it's really quite easy. And as you have seen, Empress and UPX technically use a similar strategy, just different functions. So more cosmetic differences in how they do the packing, but ideally the concept is just the same.